Hi everyone, I hope you are doing well and I am excited to show you my DevOps demo project. First of all, let's discuss about the source code of the project. The project name is crop price dashboard and which shows the local market crop prices and predicts short-term trends. And here is the source code of my project, and as we can see several microservices are used in this project like Java, Go, React for Frontend, Python, Node.js and MySQL as database. So if you download this repo and run the command docker compose app, and then you can see the project. Let's go to the project demo. I am running this project currently in my localhost 3000, which calls the React components. And if I go to the project dashboard, I can see that I can choose the crop, which can be rice, wheat or lentils, and I can also choose the region as well. Suppose if I choose lentils and regions as Chittagong, then I can see the historical price and predicted price of lentils in Chittagong area. Let's go to the project architecture again, and here is the project. The dashboard is pretty simple. Yes, it's the workflow. What happens, I can explain you in simple words. When the user opens the React frontend like on port 3000, and when you choose a crop and a region, the frontend sends a request to API gateway, which is built with Java, and then the API gateway plays the role of the manager. It calls the data service, which is written in Go, to fetch historical data from MySQL database, and then it calls the trend service, which is written in Python, to predict future prices using that historical data. And we use writer service, which is written in Node.js if new data needs to be inserted. And then API gateway merges both historical and trend data and sends it back to the front end, and then the front end shows us the data in two lines, one for historical price and another one for predicted trend. And you can run this using docker compose app. Currently I am using fake demo data in the front end only to simulate backend responses, because my main task of this project is to DevOps and microservice integration. All backend service APIs and dockerized components are fully functional. Using mock data simply makes the front end instantly viewable, nothing else. Now let's go back to our main agenda of this project, which is implement DevOps. Okay, now let's move to the main part of our demo video, which is implementing DevOps. And to implement DevOps, first we need to build multi-stage Docker file for each microservice to ensure reduced image size and remove unnecessary build artifacts. And then I will upload those images to ECR so that EKS can pull them, and then I need to write necessary Kubernetes manifests for each microservices, where it will contain YML codes for deployments, services, and config maps, secrets, ingress and namespace as well. Then I will implement EKS cluster using Terraform, and we know to implement EKS we need to create several AWS resources like VPC, public and private subnets, internet gateway, NAT gateway, route tables, security group, and then we will create EKS managed nodes, and we also need IAM roles. We will do this step using Terraform, and then we will use Prometheus and Grafana in our EKS cluster to monitoring the cluster, and at last we will implement Argo CD to enable GitOps in our Kubernetes manifest file. It's a big project, I believe, and let's implement them. Here is the Kubernetes props price dashboard DevOps. Here you can find all necessary Terraform codes and Kubernetes manifests that I just discussed. And now let's go to live demo. Before showing you the demo, I want to mention one thing. If you notice, I have source code in GitHub repo, and DevOps or infrastructure codes are completely separate and they are in separate repo. I keep DevOps repo separate from application source code to maintain separation of concerns, because it is good practice to keep app repo single, because it will contains application logics, and while DevOps repo holds various DevOps tools related codes like Terraform, Kubernetes manifests, etc. And this makes it easier to manage versions, permissions, and environments. And because as I will also implement Argo CD, so having a separate repo ensures that deployments are triggered when infrastructure or Kubernetes manifest file changes, not app codes. Okay, now let's go to our live demo. Okay, now I am starting the demo part. First, I want to show you the Elastic Container Registry part, because I will upload the images to Elastic Container Registry or ECR. And if I here is my AWS console account, and it's my account site, and you can see my account ID, which ends with 7324. And I have also configured AWS CLI for my account as well. For example, if I write the command to get the AWS account user account information, I can see that my account ID is same as I can see in the console. Now if I click on Elastic Container Registry, yes, I can see that there are 5 private repositories. All of them are my 5 microservice images, and I can also check the same thing from AWS CLI as well. If I paste the necessary command, then in the output I will get the name of the AWS ECR images, and we can do a lot of things or advanced things from this AWS CLI command reference as well. So my images are in AWS ECR, no problem with that. Now I am moving to the next part, which is EKS, because as I have shown you earlier that we have created all the necessary Kubernetes manifest file, and I have created EKS and its necessary components like EKS cluster, node groups, worker nodes, and before that I needed to create VPC or subnets or route table. I created everything using Terraform. Here is the code, and I will also explain it later. Now I am showing you the EKS demo. If I go to EKS service, then I can see that there is a cluster which is final error free EKS. Sorry for the name because I played with several EKS cluster, and this is working 100% accurate, and as it is working, so I have decided not to change the name further. And if I see the details, we can see each details, or if I go to compute section, I can see the node group which is desired state is 2, and I can see there is 2 nodes, and the desired state is 2 because I can see it. In Terraform we mentioned that our node group size, minimum node group size nodes should be 1 and maximum nodes should be 3, but desired is 2, and the instance type should be t3.medium, and that's why you can see that instance types are t3.medium. So we are done with EKS node groups and nodes, and we can see the EC2 instance as well from EC2. I can see I have 2 EC2 instances running, and these are my nodes actually, and both of them are working well. And another things I want to show you, the VPC and subnets and route tables we created for this EKS cluster. Here is our VPC, and EKS cluster VPC final, and this is the VPC we are using. And for subnets we have 2 public and 2 private subnet, and we can see that EKS cluster VPC final one, and another one is this one. These 2 are public subnet and these 2 are private subnet. And if we go to route table, there are several route table for final and private, and in the route table I can see that there is a route table named EKS cluster VPC final private, which is the route table for private subnets. And if we go to the routes, we can see that all of our private subnet are linked with net gateway with public subnet. And if I show you the public subnet and its routes, then I can see that yes, they are connected to internet gateway, and all of these things are working very fine. And we can also see the same things with our terminal using AWS CLI. Suppose if I paste the command to check EKS cluster name, I can see the name of my EKS cluster is final error free EKS. Or if I want to see node groups in my cluster, then I can paste the necessary command, and I can see the node group. And if I want to see the EC2 instances that are used as nodes, then I can also paste the necessary commands. Yes, I can see, and all of them aligns with the resources I have shown you in AWS console. And to know about EKS commands, we can refer to this AWS CLI command reference, and thus it is proved that our AWS EKS and its necessary components are built using Terraform are working very fine. Another thing, I also set up Terraform TF state remote backend, and if I go to S3 or simple storage service, I can see that we have S3 bucket, and if I go there, I can see the Terraform TS inside the EKS folder. I will be able to see the terraform.tf state file, and so thus I have also implemented state logging using Terraform remote backend. So it was the EKS and AWS it was the EKS and Terraform remote backend part, and this is working 100% accurately. Okay, now let's go to the fun part. My project is now live in EKS. I want to show you that, and before that, we already know that in Kubernetes, when we create a service type load balancer, Kubernetes ask AWS to create an external load balancer for us. Usually this is called elastic load balancer, and if I go to my service repo, and in the frontend React service YML, I have necessary annotations to create the service load balancer. I can see that I have told to create network load balancer, and it can send HTTP traffic and connect directly to pod IPs. So now let's go back to our terminal and get the service again. Yes, for the front-end React, a load balancer is created with external IP. I am going to copy and paste it in my browser. Boom, my website is now live on EKS. My website is now live, and we can browse it using EKS load balancer, and I can also choose my preferred crop and region, and I can see the chart like that I used to see using the localhost. So my website is now fully functional and working and live to the internet. Yeah, now let's move to our monitoring part. For monitoring, as I discussed earlier, I have used Prometheus and Grafana, and first let's I have set them previously. Now let's go and see the monitoring services. Yeah, here I can see Grafana is exposed as a load balancer, so I am copying the external IP, and if I paste it in the browser, and boom, Grafana is working well. And if I go to the dashboard, I can see there is a Kubernetes cluster where Prometheus is integrated. It is running inside the cluster. It collects all the metrics and pass it to Grafana. Let's go to the cluster Prometheus. can see all types of data, like number of nodes is 2, and if I also go to the deployment replicas, I see that yes, everything is up to date and all of my pods or deployments are working well. Okay, now let's move to the last part of our demo, which is Argo. As previously discussed, we will implement GitOps using Argo for our project, and I have done it already. And just to show you the demo, if I run command to open Argo yeah, now I can see that in localhost 8080 the Argo web UI is already there. Yes, here is my Argo and if I go to show you the repo and repositories, yes, I can see that I already have this GitHub repositories, and we are talking about this. And now what Argo will do, it will automatically deploy all Kubernetes manifests file, and most importantly it will sync my Kubernetes manifests from that repo to my EKS cluster. And this was the demo part. I tried to keep it as short as possible because the viewers of this video will be most of from HR department of any software or IT firm or people who have knowledge in DevOps. I just wanted to show them the demo and add this project to my CV as well. Wish I could see everything in details. It is not technically possible because if I wish to do it, the contents of this YouTube video will be more than several hours, because when someone starts to learn these things, it takes several weeks to several months to learn these things. And yeah, that's all, and that is the demo part. And if you have any questions, please feel free to ask me. I will always try to answer.